Hi guys, just going to go through this question. Someone asked if I could do it. It's an induction question when you want to prove that 2 to the n factorial is greater than or equal to 2 to the n factorial squared. Okay, so I'm going to do it a little bit differently to the way they've done it on their solutions. Okay, so just bear with me. Okay, so as with any induction, we want to test true, and this was for any positive integer, I should say. Okay, so let's test true for n equals 1. Okay, so that's our first step. Okay, so left hand side equals 2 times 1 factorial, which is 2 factorial, which is equal to 2. Right hand side is equal to 2 to the 1 outside of 1 factorial squared, which is 2 times 1, which equals 2. So left hand side equals right hand side, therefore true for n equals 1. Okay, second step, we want to assume true for n equals k. So i.e. that is 2 to the k factorial is greater than or equal to 2 to the k outside of k factorial squared. Okay, so that's what I want to assume. 3, what I'm required to prove is that 2 to the k plus 1, I'm going to put that in brackets, and square bracket that factorial is greater than or equal to 2 to the k plus 1 brackets outside of k plus 1, that whole thing factorial, and then square brackets around that squared. Okay, that's what I'm required to prove. Now remember, with any induction involving inequalities, I personally find it easier to go about this, rewriting it as a statement where you're proving something's always positive or greater than 0. So I'm going to rewrite it like this. Okay, take this one over, so minus 2 to the k plus 1 square brackets k plus 1 factorial squared is greater than or equal to 0. Cool. Okay, so that's what I need to prove. Okay, so I'm going to be focusing on this left hand side. So left hand side is equal to that. Now I'm going to expand this bit, so it's going to be 2k plus 2. Okay, that whole thing is factorial, and then minus 2 to the k plus 1 square brackets k plus 1 factorial squared equal to 0. Okay, now I can rewrite this. Remember, this is 2k plus 2 factorial. Okay, now I'm going to rewrite this as 2k plus 2. If you take 1 away from it, it's going to be 2k plus 1. And then you're going to go down to 2k. Okay, now I want all the products leading up to 2k, so I'm going to put 2k factorial. So if I do that, times that, I get back to this. Do you see that? See how that works? So I'm going to rewrite it as like that. Okay, the reason why I'm choosing to rewrite it like that is because I've got an expression up here that I can use that's equivalent or greater than or equal to. Okay, so then I'm doing minus 2k plus 1. Okay, I'm going to leave that in square brackets. I'm going to write this one as k factorial, and then I'm put k plus 1. You'll see why in a moment. And that's squared. Okay, so that times that's going to give you that expression. Okay, so because this, okay, I'm going to use the assumption here, because this is greater than or equal to, then I can say this line's going to be greater than or equal to 2k plus 2, 2k plus 1, and I'm going to sub in this guy in replace. So 2k outside of k factorial squared, okay, minus 2k plus 1 outside of k factorial outside of k plus 1 squared. You happy with that? Now, the next thing I'm going to do is this term has a 2 in it, okay? So I'm going to take out 2 plus 1. This guy is 2k plus 1. This is 2k. This is k factorial squared minus 2k plus 1, k factorial, k plus 1 all squared. Okay, so this 2 is going to combine with this term, if I'm times them together, because it's got a power of 1, to give you 2k plus 1. Okay? And then I'm going to write the whole thing out again. Plus 1, 2k plus 1, k factorial squared minus 2k plus 1, k factorial, k plus 1, all brackets squared. Now you see why? Now I've got these common factors, okay? I've got this guy and this guy, okay? There's common factors on either side. I've got a k factorial squared, and I've got a k factorial squared there, okay? Any other common factors? And I've got a k plus 1. A k plus 1 there and there. Okay, remember this term is k plus 1 squared, so I'll only take one of them out. Okay, so on the next line, I'm going to factorize out a 2k plus 1. I'm going to take out a k factorial all squared, and I'm going to take out a k plus 1. Okay, they're all on the outside of these big bracket. So what's left? I'm left with a 2k plus 1, okay, there, okay. Take away what's left on this side, k plus 1, k plus 1, just one term of that. Yeah. Okay, happy with that? Just one of those because this was a k plus 1 squared. Okay, so I need to prove that this is all positive. So when I evaluate this, what I'm going to get, I'm going to get 2k plus 1, got k factorial squared, a k plus 1. Okay, so at the moment, remember k is an integer. Okay, so k, just like this, I should write it. And I also forgot, Mr. White. I also forgot to say by assumption. Where did I do by assumption? There, that one there. So by assumption, there. And I should also write where k is an element of positive integers, z. Okay, z plus. Okay. So to finish this off, this is positive. This is always going to be positive no matter what k is. And this is going to be positive. And when we evaluate this, 2k minus k, k is going to be positive. And then you got plus 1 minus 1. Okay, you're just left with all positive values. So that's going to be greater than or equal to 0. So we've proved it. Okay, so therefore it's true. This statement is true for n equals k plus 1, and so you can say therefore by PMI, this statement is true for all n elements of z plus. Okay, hopefully that helps. Okay, keeping in mind your factorials. Okay, there's 2k plus 2 factorial. can be broken down. Okay, all your factorials are broken down. Remember, they're just repeated multiplications. I hope this helps.